In our 8-4 notes, we're going to calculate the area and perimeter in the coordinate plane for rectangles and triangles. Our first example is going to be for a rectangle. We want to find the area and the perimeter for this figure. So the first thing we need is the area and perimeter formulas. For a rectangle, the area formula is length times width or base times height. For a perimeter, you're going to add all of the sides. In a rectangle, the opposite sides are congruent, so the perimeter formula can simply be thought of as 2L plus 2W, because we have 2 lengths and 2 widths to add together. So, if we just have our lengths and widths, it's pretty easy. We just plug them into the formula. The problem with a figure in the coordinate plane is that the lengths and widths are not always given, so you have to find them yourself. In this particular picture, we're going to allow our length to be the long side and our width to be the shorter side. But either way you label it doesn't actually matter. We want to find these distances. So how do we find the length of a side? This actually goes back to our classification section. We can find the length of any side using one of two things, either Pythagorean theorem, or we can use the distance formula. It's your choice, whatever you prefer. I'm going to go ahead and use the Pythagorean theorem since it's in the coordinate plane. But again, you could use the distance formula as well. For the Pythagorean theorem, you're going to go ahead and create a right triangle by dropping a vertical and a horizontal to the particular side you're looking for. So here we have a very elongated, skinny right triangle with one side of 2, and it looks like the other side, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. Okay. All right, so let's go ahead and calculate the length. For the length, we have 2 squared plus 12 squared equals the mystery length squared. Solving this Pythagorean theorem, we have 4 plus 144. Continuing to simplify here, 148 equals L squared. And to get rid of the square, we're going to take a square root. Now, technically, you should have a plus or minus when you solve an equation with a square root, but since we're looking for an actual distance, the negative root doesn't make sense. So we're only going to choose to use the positive root in this particular type of problem. So it looks like our length is the square root of 148. This is not a perfect square, so we don't have a nice integer answer. However, this particular square root can be simplified. If you try to find a perfect square factor that goes into 148, it turns out that 4 is the largest. And I'm going to go ahead and show you just that process just to remind you about how to simplify a radical. So for 148, we're going to take that and just start dividing large square roots. So the largest square root that would go into this possibly is 144, but clearly that's not a factor. Next would be 121. That's not going to go into it. 100 is too big as well. 81 may be a possibility. If we question it, we can take 148 divided by 81. And we see it's a decimal, so that's no good. The next perfect square is 64. So if we take 148 divided by 64, we see that that also does not work. Our next one would be 49. Oops, 148. Sorry. So if we try to divide 148 by 49, that doesn't work. 148 divided by, let's see, this would be 36 next. That doesn't work. 148 divided by 25. That doesn't work. 148 divided by 16 doesn't work. 148 divided by 9 doesn't work, but turns out 148 divided by 4 does work. So we can break the square root of 148 into 4 times 37. And this is just a review of your simplifying radicals here. 4 is the perfect square, so it will come out as the 2, leaving the non-perfect root inside. So this is our reduced length. Please keep it in its exact form. Do not round to decimals in this particular section. Because if you round to decimals, when we go to calculate the area and the perimeter, your answer will be off. So even if you're not going to reduce the radical, at least leave it as the square root of 148. No decimal equivalents, please. No rounding. Okay, so let's go ahead and find the width. For the width, we're going to do the exact same process, either with a triangle or with using Pythagorean theorem, or you can use the distance formula. Again, your choice, whatever works best for you. I'm going to go ahead and use a right triangle again. Here it looks like we have a height of 1 in this triangle, and it looks like our length is 6. So, for the triangle, side squared, 1 squared, plus the other side squared, 6 squared, will equal the hypotenuse, in this case, w squared. All right, let's solve this Pythagorean theorem and get our w. So 1 squared is 1, 6 squared is 36. Adding those together, we get 37. To solve for w, we want to take a square root. So it looks like w is the square root of 37, which again is not an integer answer. 37 is a prime number, so I know that there are no perfect square factors, and this is just going to be our width. So now we have our width, we have our length, and our last step is to actually go ahead and find the area and perimeter which we desire by plugging them into the formulas. So our area formula is length times width, as we mentioned before. So all we're going to do here is plug in the length and width values that we found up above. And if you recall, when we multiply a square root times the same exact number in the square root, it essentially cancels that square root. So the square root of 27 times the square root of 27 will just get us a 37 without the square root. And we have 2 times 37, or it looks like that's going to be 74. And this is our area. There are no units. If we had a unit, we would tack on a square unit, for example, like inches squared or feet squared or whatever. But since there are no units, you don't necessarily need to put on a unit. If you feel compelled to put a unit on this area, you can write units squared. Okay. Last but not least, for this problem, we got to find the perimeter. And as we had mentioned, the perimeter formula is 2L plus 2W. So let's fill in what we know. 2 is part of the formula. The L, we calculate it to be 2 radical 37 plus 2 times the width, square root of 37. So simplifying, we're going to do our multiplication first. When we multiply radicals, we do outsides together and insides together. So for this first term, the two numbers that are outside are 2 and 2, which multiply together to get 4. And there's only one number on the inside, the square root of 37, so we leave it like that. For the second term, we have a number on the outside, we have a number on the inside, so nothing to simplify here. And then last but not least, we're going to add these by combining the numbers in front, since they are indeed like radicals. Something to note, if you did not simplify your radical in your length part, when you get to the perimeter, you would have the square root of 148, 2 square root of 148 plus 2 radical 37. And if you don't see that you could reduce 148, you wouldn't be able to get its reduced answer, 6 radical 37. So eventually you're going to need to reduce to get that final answer, either within the length calculation itself or later on in the perimeter problem. Okay, so that's how we find the area of a rectangle in a coordinate plane. We're going to find the length and the width using our Pythagorean theorem or using our distance formula, and then plug them into the appropriate formulas. So how do we do this with a triangle? Well, essentially the same idea, except we have new formulas. For a triangle, the area is 1/2 the base times the height. Now, it's important to note, a base of a triangle is not always going to be the bottom side. The base could technically be any side that you choose. However, that will also determine your height. Your height will always be the perpendicular length from the opposite vertex to the base that you chose. So if you're choosing, for example, the top of the triangle as your base, the height is still going to be up and down. But if you choose the right-hand side of a triangle, then your base would run horizontally. So your height would run horizontally. So it all depends on what you choose as your base to determine what the height is. So just make sure you're always fully aware of that. The height should always be perpendicular to your chosen base. Okay, so that's your area formula. Next, we're going to talk about perimeter. For perimeter of a triangle, we're going to add the sides. So I'm just going to go ahead and call the sides A, B, and C, but essentially all I'm doing is adding the sides. So just that's what you want to keep in mind. Okay, so in this triangle right here, our sides are A, B, and C. Now, because I'm going to have a base, I'm going to choose what my base is and label that side as my B. So here's where you want to think, okay, what side is going to be easiest to use as my base? If I try to use this side right here that I'm showing as my base, then the height is going to run vertical and therefore would also be diagonal. The same would be true for the top right-hand side. If you choose this as your base, your height will also run diagonally, which is fine. It's possible to use. However, it's going to be a lot more complicated to calculate. However, notice that if you choose one of the sides that is either vertical or horizontal, one, that side will be easy to figure out the length of, but not only that, the height will also run horizontal or vertical. In this case, since I picked a vertical base, my height would be horizontal and easy to find. So I always suggest that you find or you choose the side that is vertical or horizontal as your base. So that makes this side on the far left our base. And our height would be the perpendicular dropped from the opposite vertex to that base. So it looks like it's going to be this line right here. And that's our height. That leaves the other two sides as our A and Z. And it doesn't matter which one you call A and which one you call C. Okay, so those are our sides, A, B, and C, and our height given our particular base that we chose. Let's start off by finding the base and the height, because those are actually going to be pretty easy. The base is actually, if you just count it, it looks like, let's see, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 blocks long. The reason why I can count it is because it's vertical. If it was diagonal, I'd have to do a little bit more work. If we look carefully at our height, it looks like our height is going to be 7 units long. And again, our height we could calculate just by counting the blocks since it was horizontal. All right, so we have our base, we have our height. We're actually ready to do our area formula, but I'm going to save that for just another minute. And I'm going to solve for our other two sides. So you're going to solve for the other two sides the same way, either using Pythagorean theorem or with the distance formula. Since I did the Pythagorean theorem in the first problem, I'm going to go ahead and do the distance formula just for something a little different. So for A, I'm going to go ahead and write down our two coordinates. We have, it looks like, -4, 6. And we also have the point 3, 3. The distance formula, if you recall, is going to be difference of x's squared plus the difference of your two y coordinates squared. So plugging them in, if I subtract my x coordinates, I get 3 minus negative 4, and then we're going to square that. And if I subtract my y coordinates, I get 3 minus 6, and again, we're going to square that. And all of that will be underneath the square root. So I'm going to go ahead and simplify this. 3 minus negative 4 is 7. 7 squared is 49. 3 minus 6 is negative 3. Negative 3 squared is positive 9. And 49 plus 9 gives me the square root of 58. Now, it turns out that 58 does not have a perfect square factor. If you actually divide it by 2, you get 2 and 19, which doesn't break down any further, so there are no perfect square factors. So that's our A distance. Let's go ahead and find C. And again, I'm going to use distance formula, again, just to do something different from our first problem. If you don't like the distance formula, do not use it. Use the Pythagorean theorem, as we did in the first example. So again, for C, I need to identify the coordinates. So C also shares 3, 3. And it looks like it also has the point negative 4, negative 2. Using our distance formula, difference of x's, we're going to do negative 4 minus 3 squared plus the difference of y's squared, so negative 2 minus 3 squared. And let's compute. Negative 4 minus 3 is negative 7. Negative 7 squared is 49. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. And that's underneath a square root. Adding those together, it looks like we have 74. 74 does not have a perfect square factor. You can use your calculator to check it out if you're not sure, but this does not simplify. So we have our three sides, our A, our B up here, and our C, and we also have our height. So now all we need to do is plug these values into the appropriate formulas to find the area and perimeter. Okay, if you recall, the area formula for a triangle is 1/2 base times height. Plugging in our values, we have 1/2 the base value, which we calculated as 8, and our height, which we found was 7. So if you multiply these values, 1/2 of 8 is 4. 4 times 7 gives us an area of 28. Once again, we do not have units, so this is just 28 square units if you would like to write that, or just simply 28 with no units given. Okay. Perimeter. The perimeter is just A plus B plus C, just adding the three sides. Notice you are not using the height because the height is not one of the sides. So we would have square root of 58 plus our B value, 8, plus our C, square root of 74. Now, as I had mentioned when we were calculating A and C, the square root of 58 and the square root of 74 does not reduce. So these are the lowest terms possible. And if you take a look at these square roots, they don't match. So they're not like radicals. Since they are not like radicals, you actually cannot add them together. And this is just about as good as it gets. Traditionally, we put a whole number in front, so I'm just going to go ahead and reorder these, although you don't have to. Traditionally, we put the whole numbers out in front and square roots in order of size. So square root of 58 and then square root of 74. But you don't have to, once again. And this disgusting thing, this trinomial here, is actually your reduced answer. And there's your perimeter.